Good morning, this is your stats sensei, Mr. Spensey, and we're going to do an exit ticket on inverse norm and a confidence interval for the normal. So a soft drink bottle vendor claims that its bottles are normally distributed. That's going to be important because we don't know about sample size. With the mean strength of 157 and a standard deviation of 3. All right. The bottler took a random sample of 45 bottles, so our sample's of 45, that might be important, out of 4,000 produced in 1 hour and found a sample mean of 156.5. So we have a sample mean, which tells me this is my X bar. Okay, it says, what are the z-scores associated with the middle 94% of the sample means? So not of the population, but of the sample means. All right. But it says z-scores. Well, all z-scores, regardless, even if it's talking about the sample means, have a mean equal to 0 and a standard deviation is to 1. So since it's a z-score, this is 0. We need a lower and upper. And we want 0.94. Well, this is exactly the same problem we worked in the warm-up, but it's phrased differently because we're talking about the sample means. However, because it's the z-score, we still do the exact same thing. So we're going to go to an inverse norm. Our area is 0.94. Our mean is 0, and our standard deviation is 1, and we want center. We're going to go ahead and label those things. So probability, mean, and this is the standard deviation. And we're going to get negative 1.88 and positive 1.88, which is exactly what we had in our warm-up. And once again, it's symmetric it's symmetric, or the normal symmetric, and we're centered on 0. So we're going to have just the opposites, negative 1.88 and positive 1.8. The next question is, what interval centered about the mean contains 94% of the internal strength for the sample means? Not the population, but the sample mean. Well, our sample mean was 156.5. And we're going to be looking for a lower and an upper, and this is still 94%. Now, in the past, we've used inverse norm, but because we have a sample size of 45, and we're mainly because we're talking about the sample means, instead of using inverse norm, we're probably going to do better going to z-interval. So let's go to stat, arrow over to test, and drop down to z-interval and see what it asks for. So we're at number 7, stat test z-interval. So let's go ahead and write that down, z-interval. And we're going to highlight the word stats. Well, the very first thing it asked for was our standard deviation, and that's the standard deviation of the population, which is 3. The next thing it asked for is our X bar, which is 156.5. Then it asked for our sample size, and our sample size happened to be 45. So let's go ahead and put all that in. Standard deviation 3, X bar 156.5, N was 45, and then it asked for our C level, which happens to be 0.94 or 94%. That's the area between. We hit enter a couple times, and we end up getting 156.66 and 157.34. So our lower bound is 156.66, and our upper bound goes up to 157.34. So there's my lower, here's my upper. Well, the question is the vendor's claim of 157 possible? And 157 falls within that interval. So since 157 falls in the interval, it's plausible. Yes, it is plausible. because 157 lies within the interval 155.6 and 157.34. Now, if it did not include 157.34, it wouldn't. So let's do something different. Let's go ahead and go back, and I know this wasn't a problem. Stat test, drop down to number 7, Z interval, and let's change our sample size to 4,000. Huge sample size. And now it's 156.4 to 156.59, in which case it's not plausible because 157 is not in there. But in our case, 157 was contained, so it's plausible. Thank you for watching, and we will see you on the next one.